Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we have a very simple problem for today. Find n unique integers that sum up to 0. So you will be given an integer n and you need to return any array containing n unique integers that add up to 0. So you must remember the only constraint here is the integers must be unique, and given an element you need to return any array. So you can see that if the input is something like n equals to 5, so the output will be -7, -1, 1, 3, 4. If you add all of these elements, you are getting 0, or any array you can think of that which has unique elements and adding them would give you 0 is the answer. So how to approach this problem? It's very simple and very trivial also. There is nothing much to think about it. So let's consider a case where n equal to 6. You can easily construct array. So it is an even length array, so you can easily do things like 1. Okay, so you can place a 1 here and a -1 at the back, and something like a 2 here, -2 at the back, and a 3 here, and also a -3 at this point. So you see this array has a total length of 6, and if you add all of these elements you will get 0, because every element is negation of each other in the opposite index, in the mirror index. So this you can do for even indices. And what for odd indices? What will happen for odd indices? You will still go to, let's say, 5 by 2, you will do n by 2. Okay, so here also you do n by 2, you get 3. Okay, so as you do n by 2, you get 3, and you understand that till what we need to iterate. Okay, and for n equals to 5, you can also do a very similar things. 5 by 2 is 2, so you need to iterate till 2. So 1 minus 1 you do, then for 2 minus 2 you do, then you see that there are still 4 elements instead of 5, and 1 element is still remaining. So this is happening because this is an odd number. So in the middlemost element you add a 0. So you can do something like array of n by 2 is equal to 0. You can add this at the ending. Okay, so what will be the algorithm? What will be the complete algorithm? If you try to think, it will be very simple. You first have a vector. Okay, vector integer answer, which initially you initialize to 0, all elements 0. Okay, and then what you do, you get a for loop. Okay, and that for loop will go from I equals to 0 to I less than n by 2. Okay, I less than n by 2 and I plus plus. What you will do is very simple, is that an answer of I will be very simple thing, is that I plus 1. Okay, so the first element you are answer of 0. The first element is answer of 0, which you are placing as 1. The second element is answer of 1, which you are placing as 2. So answer of I will be I plus 1, and answer of n minus I minus 1, that is the mirror element from the bottom, mirror element from the back, that will be minus of I plus 1. Okay, and you can just do a check. You can just simply do a check also at the end. Okay, so if n is odd, okay, so what does it mean? If n module 2 equal to 1, okay, so if this is happens, then what you can do, answer of middlemost element, you will have a middlemost element which is empty in case of an odd number, as we saw in the example here. So you can just place it to be 0, and all you can do is return answer. That will be all our algorithm. I hope you can now easily code it in your own language. Okay, so I will just show you the coding. This is very simple. It will be a very simple for today. Okay, so we have a vector answer n. What it will do, what we will traverse through all the elements starting from I equals to 0 to I less than n by 2, I plus plus, and what I will do is answer of I will be nothing but I plus 1, as I had explained you, and answer of n minus I minus 1. So starting from the back, the answer will be minus of I plus 1. Okay, and if you see it is an odd number, so if n module 2 equal to 1, so I am doing just n module 2, and that answer of n by 2 should be 0. That's all for this problem, and you just return answer. So you see, you initialize an empty vector of answer and you just fill up the vector. in the algorithm which we discovered, and we will just return simply 0. This is all for this problem. This is very simple and very easy to think. There is no difficulty at all. So we can just directly try to submit it and check if it works. I think it will just work fine. So it's taking a bit of time for submission. So you see we get the accepted thing. There is 100% bits definitely, because there is nothing at all involved here. It's a very simple solution, and memory complexity is also quite good, because in the worst case you need to return an answer anyways. Okay, you will be needing to return an answer anyways. So yeah, that's all I guess. That's all for this video. It was a very simple problem for today, and I hope your day also goes as easy as the problem. Thank you so much.